MULTIROTOR G4 Surveying Robot. With this video, we would like to show you how easily, quickly, and accurately you can survey large areas using the G4 Surveying Robot. Thanks to its folding arms and collapsible landing gear, the surveying robot takes up very little space in the vehicle when being transported and, with a few simple steps, can be made ready to fly within minutes. To ensure perfect results, several control points around the airfield are clearly marked and calibrated by GNSS or with a tachymeter. After a short pre-flight check, the copter is ready to start and transmit the desired flight pattern, which is to be programmed here on site. Naturally, the flight can also be planned in advance in the office. The flight planning takes place in the MULTIROTOR ground station using a satellite image from Google Earth, which covers the flight area. This image can be saved in the office. Thus, no internet connection is needed on site in the field. Now, with only 3 mouse clicks, a rectangular flight area is defined in GeoMapWin. The WGS84 coordinates are automatically applied by the ground station. The desired flight altitude or the required ground resolution, the overlapping in the transverse and longitudinal directions, and the desired flight speed are now entered in the matrix wizard of the ground station. Now, with a single mouse click, the complete flight program is written. The estimated flight time and the entire flight route is calculated and displayed. The planned flight route is displayed in the GeoMapWin. Changes are possible by shifting the waypoints. The modified coordinates are immediately incorporated in the flight program. After the camera is switched on, the viewfinder image with all important camera parameters appears on the live view monitor on the remote control. With Send Mission, the flight program is transmitted to the copter via radio link, the copter is placed on the launch site, and the motor started. The mission is activated by a switch. The copter takes off, rises to the required height, and flies to the first waypoint. The position, flight direction, and altitude of the copter, as well as all status information, can be monitored from the ground station at all times. After the automatic panning of the camera in the direction of the ground, the actual photo flight begins. On the live view monitor, the focus and exposure of the images can be checked. You see what the camera sees. Once the last waypoint is reached, the surveying robot automatically returns to the starting point and lands automatically, if desired. After the readout of the image data from the camera and the flight recorder data from the copter, the geo-referencing of the images with WGS84 coordinates takes place in the ground station. The actual image data processing now takes place with AGI Soft PhotoScan Professional or other photogrammetric software. First, the image data are loaded into the project and WGS84 selected as the starting coordinate system. The images are now linked with the geocoding data generated from the flight recorder. In this way, each photo receives the geo-coordinate and receives the exterior orientation. In the next step, the individual photos are put together into an image mosaic, in this example, composed of 258 photos. Subsequently, markers are set in the relevant individual images and pushed to the middle of the control points surveyed before the flight. As soon as the markers are set, PhotoScan automatically recognizes all photos which contain the control point. In each photo, the marker is now drawn cleanly to the middle. After changing the date of the desired project coordinate system, in this case Gauss-Kruger, the next data exported from the GPS rover is read in with the control point coordinates. The still fairly inaccurate interior orientation is greatly improved by optimization of camera alignment or by a bundle adjustment. In practice, positional accuracy of approximately half a pixel and altitudinal accuracy of 1 to 1.5 pixels can be assumed. The next step is the calculation of the density of point clouds, for each of which the depth information is calculated. This step requires a high processing of the computer and is, therefore, correspondingly time-consuming. White flecks in the point cloud are an indication of insufficient information or strong reflections, which may occur, for example, in the case of clumps of trees, or glass or water surfaces. The calculation of digital terrain and surface models via a classic 2.5D meshing takes place via the function createMesh. The model can be displayed in various views and, in a further step, textured if desired. The production of orthophotos is also carried out with just a few mouse clicks. The orthophoto can be exported as a coherent picture or split into tiles in the desired coordinate system and in the desired resolution or size. The following output formats are possible: TIFF, JPEG, or PNG. The final orthophoto can be stored, for instance, in the CAD system for later digitalization. Finally, depending on your requirements, the point cloud can be exported and the terrain model can be exported in all standard further processing formats. We'd be happy to advise you objectively and fairly about the application possibilities of a multi-copter for your projects and to provide you with a tailor-made offer for your MULTIROTOR G4 Surveying Robot. Please feel free to get in touch with us.